Good morning, afternoon to everyone. I'm Samantha, a member of the ICCT Communications team. Thank you for attending today's webinar. The webinar today is being recorded, and we will send out the recording to all participants sometime next week. Just so everyone's aware, your microphones are on mute, and if you have questions, you can write them in the question block in the control panel to the right of your screen. After the presentation, that will last about 15 minutes, we'll have an additional 15 minutes to answer questions from the audience. Today, we're going to talk about the role of the European Union's vehicle CO2 standards in achieving the European Green Deal. The presentation will be done by Sonsoles Diaz and with help from Josh Miller. Sonsoles is a researcher on the ICCT Europe team. Before Sonsoles gets started, I'd like to introduce Josh Miller, the Modeling Center Manager, who will share a few words before Sonsoles begins. Josh?
Thanks, Samantha. The EU is the world's third largest emitter of greenhouse gases after the US and China. Transport emissions in the EU have continued to grow since 1990, even as other sectors have achieved emission reductions. In 2018, transport was responsible for 29% of the EU's economy-wide greenhouse gas emissions, of which the largest contributors are passenger cars and vans, trucks and buses, marine, and aviation. Two of the most important policies to decarbonizing road transport in the EU are its CO2 standards, which include mandatory CO2 targets for new cars, vans, and trucks through 2030. These standards will be revisited in mid-2021 for cars and vans, and in 2022 for heavy-duty vehicles, with the aim to increase their greenhouse gas benefits in line with the EU's climate targets. These include reducing economy-wide greenhouse gas emissions to at least 55% below 1990 levels by 2030, achieving net zero economy-wide greenhouse gas emissions by 2050, and reducing transport emissions 90% by 2050. My colleague Sansa will talk about our recent analysis of the stringency options for these vehicle CO2 standards and their role in achieving the EU's climate targets.
Thank you, Josh, for the introduction. So now I would like to walk you through the slides, and we'll start with some background and then touch base on the methods and results of our study and wrap up with some policy recommendations that we have distilled for the upcoming review of CO2 standards for passenger cars and vans, which is expected for summer this year. And so we'd like to start putting into context our study with this chart that shows historical greenhouse gas emissions in the EU from 1990 out to 2018, which we have split in transport subsectors. These are the colorful wedges at the bottom, and then all non-transport sectors combined in the gray area at the top. And the chart also shows the emissions reductions that the EU targets for 2030 and 2050. For 2030, we have an economy-wide reduction target of 55%, or a potential target of 55% compared to 1990 levels, which is a target that is still pending agreement with the European Parliament. And for 2050, we have the Green Deal target of reaching net zero emissions for the whole of the economy, as well as the transport-specific target of reducing emissions by 90% compared to 1990 levels, meaning that potentially negative emissions will be required in 2050 to offset residual transport emissions from the transport sector. As you see in the chart, over the past 2 decades, emissions from the economy, so economy-wide, have generally decreased, while emissions from the transport sector increased. And so the share of transport emissions in greenhouse gas emissions from the EU increased from 70% in 1990 to about 29% in 2018. And likely this share will continue to increase over the coming years, meaning that the transport sector remains a key challenge if the EU is to meet its own set climate targets. I would also like to draw your attention to the blue and green wedges at the bottom, blue for passenger cars and vans and greens for trucks and buses, which together account for about 70% of all greenhouse gas emissions from the transport sector, which underscores the importance of the upcoming review of CO2 standards for light-duty vehicles this year and for heavy-duty vehicles in the coming year. So that's it for the background. Now I would like to move on to the methods of our study. And in short, what we have done is to model induced IPAT CO2 emissions from light-duty and heavy-duty vehicles in the time frame 2020 to 2050 using ICCT's roadmap model. For light-duty vehicles, we've modeled separately passenger cars and vans, and for heavy-duty vehicles, medium trucks, heavy trucks, and buses. With considering and modeling 4 different policy scenarios, one based on currently adopted policies, that's the adopted policy scenario, and 3 more ambitious new policy scenarios driven by increasingly stronger fleet-wide CO2 targets. And so what you can see in this figure on the slide is what the different scenarios mean in terms of CO2 targets for passenger cars on the left and vans on the right. We have the targets expressed as percentage reductions compared to the 2021 baseline. The brown lines correspond to the adopted policies scenarios, and the blue lines to the new policies scenarios. In our higher ambition scenario, we assume that by 2030, all new registrations will be zero emission vehicles. In the moderate ambition scenario, this target is reached 5 years later, and in 2030 would have a reduction of 70% compared to 2021 levels. And in the lower ambition scenario, all delays by 5 years, so that we will have an 100% zero emission vehicles target or meet the target by 2040. Compared to vans, we see that the 2030 targets and later are aligned. And in the case of 2025, the case of the 2025 targets, where we also assume stronger targets than currently adopted, we have, in the case of cars, more ambitious targets as in the case of vans, where we only increase the ambition in the moderate and higher ambition scenarios, and these are 5 percentage points lower than the 2025 targets for cars. So that's what the scenarios mean in terms of CO2 targets, but there is a lot more going on behind the modeling scenes. We also consider CLF benchmarks and uptake of plug-in hybrid vehicles for cars, as well as the discrepancy between official and real-world CO2 emissions. We have one more slide on the methods to provide you with more details on the scenarios. Starting with the adopted policies scenario, we assume that manufacturers meet the currently adopted targets. Those are for cars, minus 15% by 2025 and minus 37.5 by 2030. We also consider that manufacturers deploy enough zero and low emission vehicles as to exceed current CLF benchmarks by 5 percentage points, which gives them a target relaxation of 5%. We also consider that the current ratio of battery-electric vehicles to plug-in hybrid vehicles is kept constant through the years, and a growth in the real-world CO2 gap of about 1% out to 2030. Now, in the new policy scenarios, more stringent targets, as we were seeing in the previous slide, drive both CEF uptake and improvements in IC efficiency, as summarized in this table. We have, again, blue for passenger cars and vans and green for trucks and buses. And we indicate here the years in which the 100% CEF target is reached, which span from 2040 to 2030 in the case of passenger cars and vans, and these are for trucks and buses met 10 years later, so in the higher ambition scenario by 2040. As I just mentioned, we also consider improvements in ICEs. Here are the annual improvement rates, which are generally more ambitious as the ambition of the scenarios increases. And in particular, in the case of trucks and buses, we consider that the full ICE technical potential is exploited in the time frame, in the years. So in other words, 10 years before the CEF 100% CEF target is reached. So to make that clear, in the higher ambition scenario, the full ICE technical potential would be reached by 2030, and then the ICE phased out by 2040. In the moderate ambition scenario, ICE technical potential is reached by 2035, and then ICEs are phased out by 2045. So that's it for the methods. Now moving on to the modeling results. We would like to start with the annual CO2 emissions projections out to 2050 for light-duty vehicles, again in blue on the left, and trucks and buses on the right in green. And we'd like to take a look at what emissions reductions the different scenarios can achieve compared to the 2020 baseline. So starting with light-duty vehicles, we see that all new policy scenarios achieve quite a strong decarbonization by 2050, thanks to the 100% SAF targets. In the higher ambition scenario, we achieve a reduction of 97% compared to 2020. And the adopted policy scenario just achieves a reduction of 53%, which results from manufacturers achieving CLEF benchmarks, but not increasing the share of CLEFs beyond 2030, and then additional reductions come from fleet turnover. Now, looking at the heavy-duty vehicles, we see that in the adopted policy scenario, emissions in 2050 are just 90% lower than in 2020. The reason for such a small reduction is the low SAF uptake and the increased freight activity. And then the new policy scenarios would reach a reduction of up to 91% in the case of higher ambition scenario. And we see that there is a wider range in the reductions achieved by 2050 than in the case of the light-duty vehicle scenarios due to the later ICE phase-out targets. So now in this chart, we combine emissions from light-duty vehicles and heavy-duty vehicles and look at the reductions that the different scenarios achieve compared to the 1990 baseline, which is also the baseline for the economy-wide 2030 target of 55%. And we see that in the adopted policy scenario, emissions in 2030 would be about the same level as in 1990, whereas the new policy scenarios would reach emissions reductions of up to 11% in the case of the higher ambition scenario, so that we see that none of the new policy scenarios would be sufficient to meet the economy-wide reduction targets, the reduction target. However, we see that in the case of the higher ambition scenario, the target is met about 8 years later, whereas in the lower ambition scenario, the target is the 55% reduction target is met significantly later. I think it's about 14 years later. Sorry. And so here we show again, or not again, but we show the gap to the 2030 target, meaning that in addition to increasing the ambition of the CO2 targets, we need complementary policies for the road transport, other transport sectors, and also from other economic sectors that compensate for this gap. But to give some context, emission reductions from other economic sectors in the past decade were about half of what these sectors need to meet their own 55% target, plus compensate for the gap in road transport emissions. And now I would like to look at emissions just from light-duty vehicles in 2030. We see that the lower ambition scenario is quite close to the adopted policy scenario because the uptake of zero and low emission vehicles in both scenarios out to 2030 is largely the same. And in the moderate ambition, high ambition scenarios, emission reductions begin earlier, so that 2030 emissions are also significantly or much lower than in the lower ambition scenario. And on this bar chart on the right, we have CO2 emission savings compared to adopted policies. So what we see here are those savings in 2025, 2030, and 2035. For example, this 12% means that the lower ambition scenario would reduce 12 megatons CO2 more than the adopted policy scenario by 2030, and the higher ambition scenario a total of 59, which is the sum of these three, which is roughly the higher ambition scenario would save roughly 5%, 5 times more than the lower ambition scenario. And now we compare those savings to what is needed to meet the 2030 target and see that there is a gap in addition to those 59 megatons CO2 that the higher ambition scenario achieves or reduces. We need additional about 160 million tons CO2. Or in other words, what we have here, that the higher ambition scenario would achieve a reduction of 20% compared to the 55% reduction needed or defined by the target. Okay, so far, or we just look at 2030 emissions, and now we'd like to turn to 2050 emissions, and from not only look at road transport, but the whole transport sector, so that we are able to compare 2050 emissions with the Green Deal target of reducing transport sector emissions by 90% compared to 1919 levels. For that, we develop simplified projections for the other transport subsectors out to 2050. In the case of marine navigation, we assume a 75% reduction from 28 levels by 2050, which is aligned with the target set by the IMO. Then for aviation, we have a reduction of 50% from 25 levels, aligned with the target set out by the International Air Transport Association. And for other transport subsectors, we assume a net zero. And so here in this chart, we combine residual emissions from road transport in the new policy scenarios with those from the other transport subsectors, which I didn't mention that, but these projections are held constant through the different new policy scenarios. And yeah, what we see in this chart is that in the case of the lower ambition scenario, emissions from road transport alone would exceed the 90% target. The higher ambition scenario substantially closes the gap, but still, if we add to the road transport emissions or residual emissions in 2050 emissions from the other transport subsector, then we fail to meet the target. And yeah, even if this target is achieved, we would still need negative emissions to compensate for this 10% of remaining emissions. Okay, so we have one more slide with results in which we want to look at cumulative CO2 emission savings. So far we were just looking at annual CO2 emissions, and yeah, maybe this last chart gives the impression that there is not much of a difference between the moderate and the high ambition scenario, as residual emissions in 2050 are not that far apart. But once we look at cumulative CO2 emission savings in the 2021 to 2030 time frame or 2021 to 2050, then we do see significant differences between the scenarios. So, for example, looking at cumulative savings from 2021 to 2030, we see that the higher ambition scenario saves roughly 5 times more emissions than the lower ambition scenario. In the case of passenger cars and vans, and in the case of trucks and buses, the savings in the higher ambition scenario are 7.5 times greater than in the lower ambition scenario. And now looking at the 2021-2050 timeframe, we see that the moderate ambition scenario saves about 1 gigaton more CO2 than the lower ambition scenario, and the higher ambition scenario saves an additional half gigaton compared to the moderate ambition scenario. Well, I forgot to mention that cumulative CO2 emissions are crucial in terms of climate change mitigation, are also relevant for the emissions budget perspective. There is some work from colleagues coming up on this issue, where we compare the cumulative CO2 emissions with the carbon budget for the EU. And well, that's been it for the results. Now we'd like to finish with some recommendations that we have still for the upcoming review of CO2 standards. These are grouped divided them in 4 groups. Let's say the first one regarding the ambition of the CO2 targets. We recommend setting a more ambitious 2025 target despite the relative short lead time to enhance cumulative emissions benefits, which, as I was saying, are critical from a global carbon budget perspective, and to avoid delays in CEF uptakes and IC improvements. And as for the 2030 target, the modeling shows that a target as close to 0 grams CO2 per kilometer is needed to reduce the emission gaps to the emissions gap to the targets. Then in terms of ICE efficiency, we recommend setting a cap for emissions from internal combustion engines to prevent backsliding. As we've seen in the modeling, that with the currently adopted targets, if manufacturers exceed CLF benchmarks, then they don't need to improve efficiency from ICE vehicles, but actually emissions from those could even increase, and manufacturers would still meet their targets. And so to prevent that, we recommend setting a cap. Then in terms of real-world CO2 emissions, it's important to ensure that whatever benefits come from CO2 regulation that this materialize on the road. And so to prevent the growth in the gap, and we suggest that the Commission expedites the timeline for using real-world data collected by onboard fuel consumption meters, which are mandatory from this year on, and to devise mechanisms to prevent the gap from growing, and to use the data to adjust manufacturers' official CO2 values to their real-world performance, which, according to the current regulation, would not or would happen by 2030 at the earliest. Finally, for plug-in hybrids, we recommend using real-world data from those onboard fuel consumption meters devices to adjust the utility factors and make sure that, well, ICCT studies have shown that these plug-in hybrids on the road emit 2 to 5 times more than officially assumed on average. And so to better reflect to take into account their actual performance, we recommend adjusting the utility factors, which indicate the share that the regulation assumes that these vehicles are driven electrically. And further, incentives to incentivize uptake of plug-in hybrids should be tied to the real-world performance and should be considered for those models that are designed for electric driving, for example, which are those models that are capable of rapid charging and which have limited combustion engine power. So that's it for now from my side, and yeah, and looking forward to the discussion with all of you.
Thank you, Sonsoles, for that great presentation. Now we have time for a couple questions. We don't have a lot of time, but we'll try and answer a few questions. And then if there are still remaining questions, we can reach out to people separately, or you guys can, of course, reach out to either of the 2 emails listed there. The first question I have is for Josh that says, is there a stricter scenario in which LDVs and HDVs would achieve the 2030 reduction target?
Thanks, Samantha. So the short answer is not that we've modeled, and our analysis is only focused on CO2 standards. So we fully acknowledge that other complementary policies would be needed to help close that gap, and those policies could be within the light duty and heavy duty sectors, or they could be for other transport subsectors and in other economic sectors, because the 2030 target is an economy-wide target. But our analysis does suggest that from a view of complying with the 2030 target and also meeting the 2050 target, that the CO2 standards for cars and vans and also for trucks and buses should both be strengthened to be more in line with the higher ambition scenario. So complementary policies within the light duty and heavy duty sector that we haven't evaluated, but that could be quite impactful, are especially avoid and shift measures, as well as eventually measures to accelerate fleet turnover.
Okay, great, thank you. Next question will be for Sonso. It's more of a hypothesis. Someone is curious about your hypothesis for the car renewal. Do you consider a faster, slower, or identical speed of car renewal in the EU?
I was wondering if the question refers to the same car renewal across scenarios, or whether, I mean, this is actually a question rather for Josh, who is the expert on the modeling. I think our assumption is like regarding car renewal is held constant across the different new policy scenarios or policy scenarios, and that the renewal for vans is lower than for cars. But Josh, could you add to that?
Sure. So we're happy to share the assumptions about fleet renewal. The way that we characterize that in this analysis is we don't assume a substantially faster or slower fleet turnover than has been observed with historical patterns. So we backtracked out survival rates from projects like the TRAX project and compared that with sales and stock data to figure out what are reasonable survival rates for each vehicle type. And so we propagate those throughout the model. So under a future scenario in which there were a large-scale accelerated fleet renewal program, that would accelerate the turnover of the vehicle fleet, and that's something that we haven't modeled here. So it's definitely a possibility, but not something that we've considered in this analysis. One point I would make just about fleet renewal is for passenger cars and vans, that's going to make sense really only when the new fleet is very, very low emitting, so close to zero. So if we can get the new fleet as close to zero as possible and then follow that up shortly with the fleet renewal program, then that would have the greatest emission benefits, because all the new vehicles that are additionally coming into the fleet would be close to zero emission.
Okay, so we have another question that's probably for you as well, Josh. Someone would like to thank us for the tailpipe focused insight, but they noticed that there's no mention of the life cycle considerations, which is being considered by legislators for the timeframes discussed. So the question is if there's any rough idea about how the scenarios might change with this in mind.
Yeah, so here I want to just unpack the difference between fuel life cycle, which is covered in the paper, and life cycle, which would also include the vehicle manufacturing and end-of-life processes. And so in this case, we do consider upstream electricity emissions that would be needed to power battery electric vehicles and plug-in hybrids. And so that data is provided in the paper for in terms of well-to-wheel or fuel life cycle emissions pathways. And we see largely similar trends for road transport in terms of percent emission reductions by scenario. From a vehicle life cycle perspective, personally, I take the position that we should regulate those emissions separately from the vehicle operation emissions itself, and that's because those are different regulated entities. So manufacturers, well, they're different regulated entities when we think about the whole spectrum of life cycle analysis and the different processes that are covered. And so it's much more, say, bite-sized to develop policies that cover vehicle operations separately from factories or production plants. And trying to capture everything in one regulation would be, I think, quite challenging and would slow down the whole process, when really what we're seeing here is that we need speed and we need a coordinated policy approach that covers all of the relevant bases.
Okay, so we're also getting quite a few questions about the use of e-fuels and a more holistic approach to the well-to-wheel approach. So they're just kind of wondering if that has been considered at all. The issue of green energy, alternative fuels. If you could just talk a little bit about that, maybe we could answer a couple people's questions at the same time.
Yeah, I'd say point you to that section in the interest of time, but the high level point is that the expected cost of e-fuels far exceeds that of battery electric vehicles. And so from a perspective of transitioning passenger cars and vans to zero emission technologies, from a consumer benefit and societal cost standpoint, which is going to be addressed in a separate paper. But from those standpoints, our findings are generally pointing to e-fuels as being very, very expensive, and electrification as a much more cost-effective alternative.
Okay, thank you. We have time for a couple more questions. These we should get through pretty quickly. Could a more stringent 2030 target coupled with the current 2025 ambition be ambitious enough? Not sure what the overall goal of the ambition is, but if someone could just talk a little bit about that. I think people are curious to know if the plan is ambitious enough for the type of results we're looking for.
I'm not sure if I understood correctly. So the question is whether just increasing the ambition of the 2030 target would be enough for meeting the 2030 economy-wide target of 55%.
Yeah, so the question is, could a more stringent 2030 target coupled with the current 2025 ambition be, I guess, a good enough goal? Is it ambitious enough?
Okay, and I think by target, this is referring to the CO2 standards for light-duty vehicles. Like if those are strengthened for 2030 but not for 2025, is that ambitious enough? So here I draw your attention to the section in the paper on cumulative emission benefits. What we find is that the cumulative emission benefits of higher ambition, that includes strengthening the 2025 targets, those are much, much greater than the cumulative emission benefits of the moderate ambition and lower emission scenario. So when we look out to 2030, 2035, in that time frame, cumulative emissions over that time frame really rely on tightening the standards in 2025 and tightening them a lot in 2030. And looking long term, the impacts in terms of annual 2050 emissions are primarily driven by what is the date of reaching 0 grams per kilometer or close to that. So the short answer would be from a global climate perspective, and we have a blog focused on carbon budgets and that concept coming out pretty soon. That will delve more into that issue of cumulative emissions and what can be done and how does the emissions pathway under these standards compare with the physical constraints of the climate system. And that's when cumulative emissions matter much more. So I'd say stay tuned for that, and that will shed some more light on this question.
Okay, thank you, Josh, for that. To round this out, I'll just ask one more question. This one is about the heavy-duty scenarios. The question is, have the HDV scenarios considered the recent announcements of truck manufacturers to go fully fossil-free, i.e. largely zero emission by 2040? Will this likely result in a significantly accelerated ZEV market uptake in the 2030s? I think Sanso might be able to answer this one.
So am coming back to the scenario definitions. If I understood correctly, what this announcement would be in line with our higher ambition scenario. And to be honest, I forgot how the question continues. Samantha, sorry, can you repeat, please?
Sure, no problem. Have the HDV scenarios considered the recent announcements of truck manufacturers to go fully fossil-free by 2040? And will this result in a significantly accelerated ZEV market uptake in the 2030s?
Yeah, so yeah, then that would be aligned with our high ambition scenario, and that would mean that in the years leading up to 2040, we would definitely have to see a increased uptake of zero emission trucks in order to be able to reach the target by 2040, which I think in our scenarios, I'm not the expert for the heavy duty side of the study, but my understanding is that these are aligned with California's regulation, which would be similar to this target that the person is referring to, set by manufacturers.
Sure, and I'm happy just to add a little bit here. So taking the specific example of the Volvo Group and their 100% fossil fuel free targets, those include principally battery electric and fuel cell electric vehicles, but also some bio-LNG and some other biofuels in the 2040 timeframe. So in that sense, we're talking only about zero emission strategies, so battery electric and fuel cells. And so that would exclude bio-LNG and biofuels. That's something that we haven't modeled in this analysis. So that's one difference. But apart from that, they're largely similar.
Okay, thank you to you both. Unfortunately, we don't have a lot more time for questions. There are a lot of questions that haven't been answered. If your question was one of the ones that we didn't get to, I would encourage you to write to either Josh or Sanso with your questions so that you could get those answered. Again, we will send out the recording and the slides of this presentation. And the slides will also be posted on our event page where some of you might have registered for the event. We thank you all for joining the event today and hope to see you at an event soon. Thank you so much.
Thank you.